All right. Square roots. So they look kind of funny. And if you think about it, there's a reason if you really think about why they look the way they do. They go off kind of like this. I'm going to call this a start point. I'm going to call this a direction point. Because that's how we're going to label them as we graph them. Now, if you think about why it doesn't go off forever, girls, in both directions, there's a reason, okay? What kind of restrictions happen when we're talking about a square root? It's got to be positive under the radical, so it can't just plug anything in. So that's why it's kind of half of a graph looking. It can look like that, or
dang it.
It can look like this.
That's negative, ain't it?
With a start and a direction point. That's if it's, yes, if it's negative in the beginning in front. All right, so I'll give you a chance to copy that. And with a parabola, if the A in front was positive, it opened up. And if the A in front was negative, it opened down. This is the same kind of thing. This would be a positive A, and this would be a negative A in front. So when we look, that's what the graph looks like. Let me show you what the equation looks like, and then I'll give you your step chart on how to graph it.
I can't see, Gil.
All right. So several of you said it looks like we've done this before. If you think back, and you don't have to write this, we did vertex form of a quadratic that looked like this. So it looks very, very, very similar. The difference is instead of an exponent, it's a radical. Okay. All right. Now let me tell you a couple things. Okay. The A does the same thing it's always done. If it's positive, then that graph opens up like that. It looks like it kind of increases. But if that A is negative, it's going to go down. Okay, those are two different graphs there. And then we can also tell just by looking at this formula, this equation, we can tell what the starting point, remember I told you this is what I called the start point? We can tell what that start point is by just looking at the equation. What do you think it might be? Somebody said part of it.
Oh, you know, positive.
Looking at this formula.
It's positive.
I'm looking for a point. HK. But remember when we did H before, when we were in that quadratic? The H has to be opposite. And I'm going to plug some numbers in just a second whenever I show you how to do it. I just really wanted to.
H has to be opposite?
Yeah.
Okay.
No, whatever, since it's minus. So if I had the square root of x plus 1 minus 3.
It would be a negative. The negative. I mean, the positive one would be a negative 1.
Right. My start point would be negative
it's
1.
like
It's exactly what we were doing. Yes, with that.
Just do the opposite.
My dog. Mom.
If H or K are missing, what do you think they are?
Negative 1 or positive 1?
Ah!
Zero.
0.
Yo. If you let your kids like that when they about to be.
All right, so I'm just setting up a step chart for you, and I'll give you just a second to copy it and all.
I like this.
I know y'all like step charts.
I do. They help me out a lot. Like that last chapter we took, you should have gave us a step chart because you didn't give us a step chart.
All right, so the argument is which one's H and which one's K. H always stays under the radical. K is always outside the radical. So this is your K. Your H is not there, which means your H is
So
0.
0.
and 2.
All right, y'all ready for the first step?
I like this.
It's easy. These are easy to graph.
I like
All right,
that.
first step is to graph your starting point, okay? Your starting point is going to be HK. Remember that your H is opposite, your K is same.
Hold on, wait a minute now.
H is opposite.
Okay, homie. You can't see the pink color?
I can.
Okay.
I can.
White just needs some glasses. What if we had pieces of purple in this world for real?
All right, so what's the start point, DeAndre, on this one?
Come again, say what?
What's
The start point is H and K.
what is HK in this example?
X and 0. I mean 2 and 0.
Can you see that color better? Okay. 0, 2. So that means 1, 2. This is what I call my start point. And you really want to label it. If you don't label it, you're not going to know where to put your pencil to start. You're going to get confused. Okay.
Your X is always H.
The one that's under the radical with the X is your H. So here it would be 0.
Yep. That's exactly how I got mine.
All right. Okay. Tell me when you're ready. Okay. The coordinate of the point is 0, 2. So the 0 went under the radical. Is that your question?
No, where do you put the 0 on the graph?
The point 0, 2, you go 0 on X and up to 2 on Y.
So how would you know whether they go like that?
Well, we're not finished graphing yet. We got to finish. We got to find another point. We got to find what we call the direction point.
So you just gotta find 2 points.
Correct.
Any
A
2
square
points.
root only needs 2 points. The starting point has to be one of the points because you have to know where it begins.
So I would put the starting point at 0.
All right, but look. No. Your start point has to be your HK.
My HK is 0.
In this one, yes, but maybe not in every one you do. All right. For the direction point, okay, the easiest thing for you to do is just go 1 past the start point. Remember, that's what we did with everything else too.
1 past the start point?
And plug in.
That's weird.
So we took the H and added 1 and then plug in. That's the same thing we did with parabolas.
That's wild.
So here, if I started at 0, what's a good point to use for my direction point? 1. Okay? Now, if X equals 1, how do I find what Y goes with that?
How does X equal 1?
Because you always put a 1, you always replace the X with 1.
No, you always go 1 over from where you started.
So if it was 3, X would be 4.
Correct. If your start point was 10, then your X would be 11.
So
that you
my
plug
start point was 0.
1.
0.
1.
0.
If your start point was 0, then your direction point would be 1.
That's what I'm saying.
Yes,
You said
yeah.
1. You was like 1. 1. And then you started having debate
So
with me.
just say it was -1.
When we get to cube roots, it won't be quite as important, but it's real important with square roots that you move to the right, that you add numbers, that you don't go backwards when you do your direction point. Otherwise, you'll end up with negative under the square root, and we can't have that. All right, so y equals 1/2. The square root of 1 is what?
1.
So 1/2 times 1 plus 2.
1/2 times 1. Wait a minute. The square root of what?
The square root of 1 is 1.
Oh yeah, because 2 is out of the from under the square root.
Correct,
It's
correct.
the sun.
5.
1/2 times 1 is 1/2. And 1/2 plus 2, girls, y'all gonna have to quit talking, is 2.5. So this direction point then is 1, 2.5. All right, so 1,
Wait, Miss McGee, I can't see the bottom. Is that? Oh, never mind.
1, 2,
Oh my God, that's
halfway
so
up.
easy.
So this is my direction point. Put your pencil on the start point and connect.
Oh my God.
It's 1 what?
Let's do an example, start to finish. Let's do y equals,
1/2.
let's do -2 times the square root of x plus 1 minus 3.
Are you ever gonna have one that has like a number for y?
No, it's y equals so we can graph.
Oh, wait.
I forgot already.
All right. Looking at this equation, should it open up or down?
Down.
Down, because that, good job, good
Because
job.
the 2 is a negative.
All right, so my start point, what are the coordinates of my start point, Kevin?
-1.
Negative, good job, good catch. That's okay, that was a good try. -1, -3, because we have to change the sign of the H, okay?
The last one?
No, you didn't.
It was 0.
Oh, well, yeah.
It was 2.
No, 0, Trey.
H was 0 in the last one.
Come on, Trey. It was 2, 0.
K was 2. H sits under the radical, remember? You with me?
What were you doing, Trey?
All right, don't be ugly.
Trey
Call me.
my Leroy.
You told me to say Leroy.
-1, -3. I'm going to mark it with an S because it is a start point, okay? Now, Trey, what X should I use for my direction point?
Hold on.
Oh, wait, don't answer that yet. What? All right, Trey, look at my start point. What's a good X to use for my direction point?
Oh, I got it.
Y'all stop whispering it. Tell him I can hear y'all from here. What do you do? What do you do? I won't put you on the spot like that.
You add 1, right?
You add 1. So where am I right now? I'm at what? -1. So if I add 1 to that, I only asked you because you used this as an example whenever I was explaining it the first
Why would
time.
you use
Oh, so it's 0.
So it's 0, exactly. If I add 1 to this, I get 0.
Oh, you gotta add. I'm about to get mad,
Then
bro.
you plug that in.
Absolutely. Then I plug that in. So y equals -2.
I'm about to get mad, bro, because you doing something else.
No, DeAndre, what else are we doing?
Something.
What?
Oh. So what you do, you take the negative that you get from the +1 and you just break it down and you, no. Alright.
Hey, I'll be gone with
All right.
Did you say, Kevin?
Always.
you.
All right, simplify under the radical first because radicals are grouping symbols. So -2 times the square root of 1 minus 3. The nice thing about this is if you do what I told you with the direction point where you just move 1 to the right every time, you'll always get 1 under the radical. And
Oh, wait a
1
minute.
under the radical is an easy.
So what you gonna do? What you gonna do?
No, for faith.
What you gonna do with what you gonna do with that 0?
What's 0 plus 1? So now I got -2 minus 3, which is, shh. Stay focused, guys. What's -2 minus 3? -5. Shh. So what are the coordinates of this point?
-5, 0.
Close.
So you start from the middle, go down 5.
Oh,
That's right.
And then you do a little thing like this, down. It's negative, no?
3, 4, 5.
I mean, Leroy.
This is my direction. They're really, really easy graphs to do.
I will give you sorry.
One more example. Let's do,
make it a hard one, Mr. B.
Ew, like
Man, you talk too much now.
no, I don't want to do that.
Do 18.
That's it. That's all I'm going to give you. I want you to graph.
Come on. Y'all like this hard to do.
Right.
Yes,
Okay.
ma'am.
All right.
Don't teach it,
Negative
let us
zero?
do it.
Okay, you try it. Recording. All right, 0, 0, correct, because you're missing both. So it's going to start at the origin.
Yep.
Now I need my direction point.
Your direction point is 1.
Because what?
Because 0 plus 1 is 1.
Plug it in.
So it'd be 1 plus 0 plus 0. Check.
Okay. So you should have gotten 1/3 for your y.
So 1/3 times 1.
So 1, which is,
1/3.
okay. So somebody asked, how do you plot that?
Go over one,
Go over 1
and then put one on that one.
and just go up about 1/3 of the ways to
Okay.
1.
Or just make your dot really big. So like,
Well, the reason you can't with square roots is there's no graph over here. If you subtract 1 when you do it, you would get 1/3 times the square root of -1, and that would be an imaginary number. We're only graphing real numbers right now, so that's why you can't. Good question, though. All right. Nope. Now we gotta do cube roots. Ready? Oh, y'all are acting like that, but when you see it, you'll go, "Oh my gosh, that's so easy."
Let's see if you should make it as easy as this.
Yes.
Anybody have a slice?
We got
All right, I'm gonna set up. Actually, let me show you first.
I need some more paper, man.
Ryan. There it goes. Nope. Okay. All right. I'm still gonna have a start point.
Yep.
I'm still gonna have a direction point.
Nope.
But I'm also gonna have a second direction point. And if you think about it, the reason you told me you couldn't have a negative under a square root, that's a good way to remember though, Trey, absolutely. But I can have a negative under a cube root, I just can't under a square root. So here I'm gonna have 2 direction points, and it's gonna kind of look like a stretched out S. It's gonna look like 2 square root graphs put together, is what it really looks like. So it could go that way, or,
Yeah, I was gonna ask you.
and it doesn't matter which one's D1 or D2.
I'm going D2.
Okay, but that has to do with the A being positive or negative again in front.
Hold on, Mr. V.
Okay. While you're writing that, tell me, what does a cube root look like as far as the notation?
You got a 3.
It's got a 3 that sits right in the little chair looking thing, right? What's the implied number outside of a square root? 2. How many points did you need to graph a square root? How many points you think you need to graph a cube root? Good way to remember that, the 2 and the 3. Okay.
Yeah.
All right. This one looks exactly the same with one exception.
They got a number in front.
What's the exception? What's different? The 3, that's the only thing different. My start point is still HK. Opposite H, same K.
Hold on, wait a minute, pal.
Let's set our chart up.
Yes.
You switched all -1.
The H changes signs, the K stays the same.
You didn't. Let's say
Why is your H negative on one side and on the other?
Ain't it supposed to be plus?
no, it's just anything.
No, yeah, it's whatever. You keep the same sign that goes with K, you change the sign on H. All right. I hope you will find that this is easy because the steps overlap so much.
It's easy to be.
Step 1 on this is the same thing that you did before. We find and graph our start point, okay? Remember, H is opposite, K is the same. Absolutely. -4, -1. So that step's exactly the same. That shouldn't throw anybody, right?
Wait.
Okay. Can I plot it?
Yes.
Yes, ma'am.
I am going to put a D here so I remember that one's in the middle.
Oh, so that's not the start.
I'm in S. I'm sorry. Ah! S. Let's start.
So Mr. G, when you, like, say for instance,
When we're graphing square roots, what's step 2? Shh, guys.
you gotta go down, like, go up, right?
That's right. So I'm going to call this direction 1. I'm going to do h plus 1 for my x. Just like we did before. We added 1, and then we plugged in.
So it's the exact same thing.
Exact same thing. Nothing new yet. So what x am I going to use? Negative 3. Negative 4 plus 1.
So use the H from
Oh, Mr. McGee, I got confused.
All right, what's negative 4
Yeah.
plus 1? Okay. I'm going to plug it in.
I'm gonna crack my phone.
What is negative 3 plus 4? 1. So I got 3 times the cubed root of 1 minus 1. What's the cubed root of 1? 1. So I got 3 times 1 minus 1, which is 2. So exactly, Dwight, it's negative 3, 2. Okay, I'll wait. Let me plot this point and then I'll pause it a second and let y'all catch up with me. Negative 3.
What happened to the square root?
All right, so now there's an extra step in here because it's a cubed root, not a squared root. So what I want to do is I want to find my second direction point. For this one, instead of adding 1,
You subtract 1.
I'm going to subtract 1 and then plug in. Now, don't subtract 1 from this. You go back to that H and subtract 1.
So that'd be
Negative 5. Because what I want to do, I want to make sure this start point is in the middle. I want to go to the right and left of my start point. Okay? I'm going to plug this in. So I got 3 times the cubed root of negative 5 plus 4 minus 1. That's right. This time, and this is where it's different because remember, we couldn't have a negative under the radical when it was a square root. But what times itself 3 times gives you negative 1? Negative 1. So this becomes negative 1. I'm out of room.
That's a 1. It's a negative.
Negative 1.
It does. I thought it was a
So negative 3 minus 1.
It's positive. No.
No,
It's
no.
negative 4. Negative 4.
That's correct. So what are the coordinates of this point? If you can graph a square root, a cube root is just one more step there.
Why does it say negative?
Why does what say negative?
Why does it say negative?
So this means you're
It's
down
like
like
magically just changed to
No, because what's the third root of negative 1?
negative 1.
Negative 1. What's 3 times negative 1?
Oh, okay, sorry.
That's okay. So negative 5, 2, 3, 4. Negative 4. So this is my second direction point. Ran out of room a little bit there. I apologize. Does that make sense?
Yeah.
Let's do one more example before I give you your. I'll give you a second to catch up. Let's do, and I'm gonna put it in function notation.
She wanted to hit us with the gangster problem. Because you know gangster is hard, so it's a hard problem.
Tell me what, guys. Tell me what's my starting point
The
here.
starting point is
5.
5.
Is it?
Five. No, it's 5
It's negative
plus
5
0.
plus 0.
Why, Lakiana?
Because you gotta switch it.
Thank you, Lakiana. Negative 5, 0. Because you got to switch that H, and the K's not there, so I have a 0 for K.
You're so right.
All right. 1, 2, 3, 4, 5. I'm gonna put an S on it. Anybody confused at this point? All right. Now let's do our D1. What is the first direction point? What should X be? -4. Why? Exactly. Plug it in. Does it matter that this is g of x and
No,
not?
ma'am, that don't got nothing to do with
You are
the
exactly right. I'm gonna plug -4 in.
Actually, it's GX, not Y.
But it doesn't matter. You can change it to y to find the y coordinate.
Whatever you feel, make you feel.
What's -4 plus 5?
1. Positive 1.
Positive 1. And the cubed root of positive 1 is
1,
1. So -2 times 1 is.
-2,
So my first direction point is.
-4, -2.
1, 2, 3, 4. 1, 2. First direction point.
Hold on, wait a minute.
Which is -6.
Hold on, wait a minute.
Okay, tell me when you caught up.
-6 and 0.
Yeah. -2 times the cubed root of, not -6 and 0, I just chose -6 and I'm plugging it in. So what's -6 plus 5? -1. What's the cubed root of -1? -1. What's -2 times -1? 2. Give me the coordinates of my second direction. Yes.
Cause you going like a roller coaster right
Am I? I'm sorry. I'll hold up. -6, 2. All right, so there we go.
That was I thought that was -1.
Don't connect these into a line, guys. Don't come on your graph and do this, because it definitely, I want to see that you know that it curves. And if you don't, I'm going to make you plot some more points with it. Okay? All right. Let me